Okay, so we're going to start by looking at number 4 in the homework. And this one we're talking about a spherical balloon that's being inflated at a rate of 18 feet cubed. So this is our first given. It's going to be our change in our volume. And we know it's volume because of the 3 right there, because we're talking about feet cubed. We're talking about our change in volume over time. It's 18 feet cubed per minute. We have another given here that when the radius is 2 feet, so when our radius r is 2 feet, we're looking for how fast the radius is changing. Right? That word changing tells us we're looking for a rate. Our dr dt is what we're looking for. That's our end goal. Then they're also nice enough to give us the actual equation for the volume of a sphere. So now that we have all of our givens worked out, we're given our equation, we're going to jump into taking the derivative. So we're going to derive in regards to time on both the left and the right side of the equation. That's going to give us dv dt equals, this is just the power rule, 4 pi r squared. And then, of course, we got to tack on our dr dt. And now that we have our derivative, we can plug in all of our info. So we're going to plug in our givens. Right off the bat, we have our dv dt is given to us up here. And our radius is 2 feet. And we're just left with our singular variable dr dt, which is what we're going to be solving for. So we can simplify this down. It's going to give us 8 pi, slow down there, sorry. So this is going to be 4 pi. When we square this, we're going to get 4 feet squared. Or we can simplify this side to just be 16 pi feet squared. Okay, now we just have to solve for our dr dt. So this is our solve step. Dr dt is going to be our 18 divided by 16 pi, and our units are just going to be feet per minute, which makes sense because we're talking about our spherical radius here. That's just one-dimensional. We're just talking about a singular foot. There's our answer to number 4. Now, if we're going to write out that sentence, right, be good math students here, not be the lazy math student I want to be. I'm going to write out that full sentence here. So what this is telling us is that when the radius is 2 feet, the length of the radius is increasing at a rate of, and we can simplify that fraction down if we want. We can say 9 over 8 pi feet per minute. Alrighty, there you go. We got our full, complete sentence, including our proper units. Okay, so we're going to skip ahead here to 7a. This is a multi-part question. We're just going to be doing A and B in this video. And this one's nice. They give us a whole little picture here. We're just going to add to it. So first, it lets us know that we have a 10-foot ladder. So our hypotenuse of our triangle here is 10 feet. And it's leaning against this house, making a right triangle. The base of the ladder is pulled away from the house at a rate of 1.5 feet per second. So we're talking about this base as the ladder gets farther and farther away from the bottom of the house. So we're talking about the rate dv dt is 1.5 feet per second. So every second, this ladder is scooting a foot and a half away from the house. And then finally says at the instant the base of the ladder is 6 feet from the house. So again, we're talking about this distance b. So we're going to be measuring at B equals 6 feet. All right, now part A is asking us to find the rate at which the top of the ladder is moving. So now we're talking about the top of the ladder here in regards to the bottom of the house. So we're talking about the rate dA dt. That's our goal for part A. Trying to find how fast the ladder is scooting down. Before we jump into that, there's one hidden given that we can find that'll make our life a little easier down the road. So currently we're looking at a right triangle whose side length is 10 for our hypotenuse and 6 for this. And we're just looking for this missing side A. And we can find this pretty easy using Pythagorean theorem. If you want to spit that out really quick, that's a squared plus 6 squared equals 10 squared, and you solve down for A. Or you might observe that we're actually looking at a 3, 4, 5 triangle. They just have a ratio of 2. So this bottom one is 6. That means A must equal 8, according to our 3, 4, 5 triangle. All right, now that we have a whole bunch of givens here, we know A, we know B, we know the rate B is changing. We also know the distance of our ladder is 10 feet. Now we're finally ready to look at our equation, and we're going to be using our Pythagorean equation. Okay, so we're looking at A squared plus B squared equals C squared. Now in this problem, our hypotenuse here, it's constant. The length of our ladder is never changing. It's always going to be 10 feet. So because that's never changing, we can start by plugging that in even before we take the derivative. Okay, now we're going to go ahead and move into our derivative step. And we're deriving in regards to time on both sides. So we're going to end up with 2a dA dt plus 2b dB dt equals 0. Now we're going to plug in all of our givens. All right, so we've got a equals 8. dA dt that's our variable. That's what we're still searching for. Our b is 6, and we have our dB dt rate right there, 1.5. So we're going to calculate this down. That's going to give us 16 dA dt. Let's see. Plus 18 equals 0. And then we just have to solve for our variable. So we end up with dA dt equals negative 18 divided by 16. And we just need our units. This time we're just talking about distance. We're talking about feet per second in this problem. Feet per second. Now, what this means in regards to our actual problem here is that the ladder is scooting down. It's getting closer to the floor. So our distance A is shrinking. That's why we see this negative here. So the distance A is shrinking at a rate of negative 18 by 16 feet per second. Or you can simplify that down to just being dA dt is negative 9 over 8 feet per second. Okay, so now we're looking at 7b. We've got all the same givens from the problem before. Just this time, we're looking for the rate at which the area of the triangle is changing. So this time, we're talking about an area of a triangle. Just to remind you, the area of a right triangle is going to be 1/2 times AB, right? Our two side lengths. It's half length times width. Now, we have lots of the same givens from the problem before. For instance, we know A is 8 and B is 6. We have the change in our B over time is still 1.5. And this last problem we found dA dt is that negative 9 over 8. Okay, so now we have lots of givens all listed out for us. All right, I'm going to go ahead and shorten area just to be A, and then we're going to jump straight into our derivative step. Again, we're deriving with regards to time. So we're going to have dA. I'm going to use the capital A to denote our area. dt. Okay, now we're going to be really careful here because we're actually looking at a product rule. I'm going to leave that 1/2, the constant, on the outside, and we got to do our product rule on the inside. Okay, so just remember our one function is A. The derivative of that is dA dt. Our other function is B, and the derivative is dB dt. Woo! Okay, so when we do product rule, we're going to really say B times dA dt plus A times dB dt. Woo! Okay. Once we're here, we're ready to plug in, and we're going to plug in all those givens that we have above. Now, dA dt is what we're looking for, and it's already solved for dA dt, so that's nice. Our 1/2 is chilling on the outside here. Now, our B is 6. dA dt we found in the last problem is -9/8. 8 is A, and our dB dt is 1.5. Okay, so we can do some mental math here or plug in a calculator. We're going to end up with 21/8. And again, we're talking about the change in area. So we're talking about not just feet per second anymore, we're talking about feet squared per second. And that tells you the change in A over time. And if we write this out as a full sentence, we can say the area of the triangle is increasing since it's positive at a rate of 21 divided by 8 feet squared per second when the base is 6 feet long. All right, and that's it. If you have any more homework questions, you feel free to email me them or send them on Remind, and hopefully we can cover 1 or maybe even 2 tomorrow, though it is a very short day in class tomorrow. Please make sure to review your homework through the whole section for our homework quiz tomorrow. See you guys bright and early.